Hi, I'm Struppi and I'm part of Fuller Feedback Systems, and today I would like to share with you some insights into the state of the world, why we are where we are, and how we can get out of here. So, in order to make sense of our situation as it is, we need to take a hard look at the way that we've learned to make sense of the world, right? So, how do we learn to make sense of the world? Where do we do it? And what's the tool set that we're using, the framework for that? Now, what we do, the world that we're living on is the earth, right? We're part of this. We're actually grown out of this place. And most of us by now have gotten the notice that, well, it is a sphere. And all life on this planet is a sphere as well. It's a manifold of spheres. There is the aquasphere, the atmosphere, the geosphere, the biosphere, the this-sphere and the that-sphere, including the anthroposphere. And the anthroposphere is the sphere of the people, of the humanimals on this planet. And it's a bit different than all the others, it seems, because all the other spheres tend to be spheres, whereas the anthroposphere is dominated by a shape that we do not otherwise find too often, which is this one. And we tend to call this a cube, right? So the framework of this cube that we've learned, the framework of what we call space and time, the basis for that is what we call geometry, which is a Greek word. Most of these things we've learned from the Greek, from the ancient Greek, that is. And geometry means the measuring, metry, of the earth, geos. So, this geometry that we learned is something most of us have had in school. Some may earlier, some maybe later, and some may have had great fun with it, others less so. But the basic agreements, axioms as they are called, of this so-called geometry are the postulation of a couple of things. These things we call points, lines, areas, and volumes or space. And how we get to these is by a series of steps that we take on a piece of paper, usually. I mean, the Greek didn't have the paper yet. They were perhaps using a piece of stone or a piece of wood or something, or in fact the earth, the ground on which they stood. And their main tools of their trade, the things that they used to measure the world, were this thing here. This is called a compass or a divider. It's there to make circles on whatever we're drawing on. Then there is what we call a ruler or a straight edge to make a more or less straight line. And last but not least, well, I have some flying around somewhere, but one is here already. This is a pencil, so something to draw the lines with, right? So 3 tools, as it seems. The Greek were considering these 3 when they spoke of them. They were talking about divider, ruler, and pen, or scribe. Divider and ruler. What is that telling us? It's about division and ruling. And what this kind of forgets to look at is the actual surface that we've been drawing on. You know, that piece of wood, that piece of stone, the earth, and their body. Those are also part of the tool set, even though the Greek did not think of them as such. Which leads us to a problem, because what they left us with, their ideas of a point, which is infinitesimally small because it has no dimension to it. It is, really without body, no body, that point. A line that is a set of points next to one another that stretch and could go on to infinity in what we call straight line, then that does not have any depth or width to it. It's just one dimension. We continue with what we call a plane or an area, which is kind of lots of these lines next to one another, so that they give us an area, and still no depth to it, just breadth and width. And then, we go into what we call the third dimension. After the two-dimensional plane, we come to the third dimension, which is called space. And it's a static business. There's no change in space and no difference in space, because it's all made up of cubes. And some people do consider one thing that seemingly is missing from that, the time, as the next dimension. Okay, so far so good? I don't know. But it is something that we're all using every day. Like, almost everybody is familiar with the phrase 3D reality as a description of the world that we're living in. Almost everybody agrees on this, including most scientists in the world, and or let's say most people in the civilized world, because this is a civilized mindset, a civilized framework. Okay, so far so imaginary. What is there beyond the imagination? What is there really when we do look at what we're doing with these things? So, if I do draw a point on a paper, maybe just putting the compass into the paper so it leaves a little hole in there, these points and holes have a tendency to be round. So there is somebody there. There is, like, I can take a microscope and that body becomes big. The same way I can take a telescope, look at the sky, and a star, which is a point in the sky, becomes very big. Right? So there is no use in saying that a point has no dimension, because obviously every point is somebody, and they have some expanse to them. Maybe small, maybe gigantic, but there is somebody there. I'm just realizing that I'm going on to an explanation here that I do think maybe we should take afterwards, because the first thing is really just to look at that framework that we've been left with, and to look into the logic of that. Now, here is that cube, right? But this one here looks a little bit different from the one that we're used to. So far as usually this cube comes without these lines here, right? Usually when we think of 3D space, we only consider these lines. This may be a meter, and then we have a cubic meter, or it's a foot, and we have a cubic foot, or whatever. This is a very short part, but anyways. This is what we consider the normal frame of the world. Normal, in that sense, comes from this, has the meaning that it is at right angles. This is a right angle to this, to this, to this, to this. So those right angle relationships, we call them normal. Whereas this here, per definition then, becomes the abnormal. Well, what should I say? That is a very potent description of this frame, but I can show you something about it that you might not have known. Because if I do take out the abnormal part from the normal, what do you think would happen? What would happen if I hadn't had this connection here? Let me show you. Because this one is actually detachable. I can take the yellow straws here, which are bound together with a string. I can take them off of the corners here, where I have, you see, there's here some spheres, some beads, and I can take this off like so, and something's going on. Taking that off and taking off the last one. There we go. So now we have detached normal from normal. We have separated fact from fiction, or in fact separated time and space, or whatever it is. There's a lot of separation going on. But what we're left with here is two kinds of things. These are very much similar in one way, because all they are is a collection of paper straws on string. But one of them, what we have considered the normal part, has just lost all its shape. So that is not a form, but rather a transform. Whereas the other thing is still all in shape. And what this is, we'll get there. I call this a four eyes. Okay? But this one here, this is the frame of the cube as we consider it to be static space. Why is space static? Because if time is part of that, this does not hold its shape. You can see how this is incapable of holding that shape. It can transform into this, for instance, that, or can become this. It can furthermore become this, and probably a bunch of other things, but really what it can't be is that cube. That cube has lost its structural integrity. And what is structural integrity, I hear you ask? Well, there is a simple answer to that. Structure is triangle. It's not square. Square can only become structural or square, really, when we make it triangulated. And I can show you that with this one, because this can be taken apart a little further. So, just as before, I can take out these beads here from the string that's running through that place. And you see I've just opened this and suddenly it's moving. Not absolutely freely as the cube was, but it's unhinged. Like this can now fly away like a bird or a butterfly, or you can read in it as a book. And you see how this is a pair of eyes. I can see it still. I could take this off, but let's leave it there for the moment. It's easier to keep there. Let me take out the other one. Let's see what happens here. There we go. Now we've taken out both of these. All moving parts. And this here, which looks like a square sometimes, is just as structurally inept as is the cube. Right? So this is what we are supposed to make sense of as an area, or in fact a plane. But notice how there is no plane here. There is no area, no surface, nothing. What's going on? Well, again, this has to do with the Greek and then failure to notice that they were drawing these things on somebody, and that somebody was just like these connections here. They were triangulating the drawing so that the drawing would be held in place. Now, if I wanted to make this a square, I would need at least a connection between these 2 points. Sorry. Here and there. Yeah, you see the problem? Now, if I wanted to put that in as a so-called square, we would get again the problem of having this normal or rational, whereas this here is abnormal or irrational, because this becomes the so-called square root. If this is 1, this is the square root of 2. Why is it a square root? Well, I would guess that is because it is what gives our square origin and structure. So like a root of a tree, which is grounding the tree, giving it the ability to be strong and connected to the world and partake in the spheres of life and withstand something like the storms and the winds. Just like that, our square root here is what is really holding this in place, but not in plane, mind you. I can still fold this, right? So if I wanted to make it all stable, I would need a second diagonal here. But notice how we have normals and the diagonals, and those are 2 kinds of things. If we wanted to make this, measure it, and make it proper with tools, we would have to round those numbers at some point. Now if I take it out, and instead of putting in an abnormal diagonal, I would just use the same exact length as my square side is, put that in, well, we're getting not a square, but a pair of eyes, which is distinctively different from the square insofar as this has no diagonals. All of these things are triagonals. What I mean by that is that within space-time, what we're looking at now, which is what spheres are doing, you see how this is all triangles. This whole hexagon is made of triangles, and all the connections are equal, meaning they are of the same weight, the same value, the same gravity, and they have a balance in them. And all of them are connecting corners, which really, we could go into that in another talk. Those are spheres. Wherever there's a corner here, there's a sphere. And those are connected by these. And rather than having them be diagonals connecting two corners of a square that's not there, these are actually triagonals. All of them of the same value. And here we have that triagonal. But again, this is, while it's a pair of eyes and much more stable than our square was, we can still fold this. And I can show you that one of them, they are almost congruent, and one triangle like that is actually giving us what we could call, or would call, a plane. See, a plane is not 4 corners, but just 3. 3 points define a plane. And you are familiar with that, I bet, because you probably have had some interaction in your life with a tripod or a 3-legged stool or something of that sort. And you may have noticed that these things do not rock, right? Wherever you put them, however uneven the ground is, they will just stand, unless you tip them over. If you move the center of gravity over the little triangle on the ground that the 3 legs are creating, if it's out over that, it's going to fall over, it's going to tip over, but it will not rock. Whereas any furniture, any table or chair that you've had in your life that has 4 legs is bound to be walking about the place, unless you have a perfectly even and flat ground. Let's come back to that perfectly even and flat ground in a second. But first, one more look at this, because we can recombine this and that. And now we have 4 corners, and each corner, as I did show you, has one of those beads, one of those spheres in them. Sorry, technical difficulties. While this is a very, very neat kind of model, it still takes some fingers. There we go. Okay, reconnected them. Whoops, let's have a bit more light. So you see, here we have our spheres, and here is one pair of spheres, meaning 2 spheres, and here is another pair of spheres. It's a second pair. So 2 pairs of spheres coming together to make this. And you may notice that if I look at these 2 and their connection here, it is at a right angle to this one. Right? Clearly they are crossing, but not in a plane. They cross with a lot of distance between them at a right angle. But this is not a normal right angle, this is a dynamic right angle. This is what we call precession, the interaction of 2 moving bodies. In this case, 2 pairs of spheres. Okay, and that, again, let's just go back to our poor little ghost cube here that has no structural integrity as it stands. And let's reintroduce our 4 eyes into that. And you may notice I can push this in here, and then let me show you how I reconnect these corners here. 1, 2, 3, and number 4, if it might want to. No. Okay, 4 corners of the cube are necessary to make this whole thing structurally integral. Because now, as you can see, each one of these supposed squares is actually triangulated. It's made up of 2 triangles. And in a way, on this plane, on this eye of our 4 eyes in the middle here, there's a little tripod sitting. See that? So this is in itself the 4 eyes, and so forth. Okay, so now we do have something that we could call a cube. And I bet I could promise to you, or prove actually, that each cube that we find in the larger sphere of life, biosphere of our planet, each one of those cubes is gonna be made up of spheres. And they're gonna be those triangular relationships. It's just within the anthroposphere, the human sphere, the sphere of humanimal activity on this planet, there we do find solids and cubes that are supposedly static structures. And, well, I did show you some reasons why that doesn't work, right? Let's look at some more, because why not? There is more to this story. And as we're looking into the problem of the old paradigm at the moment, we should also talk about this. So if I were to realize a cube in a landscape, right? Let's say I'm building a house, and looking around today, I see that most houses that are most modern tend to be more and more cubic, whereas those that are less recent, those that are older, tend to be grown out of the landscape and into the landscape. Even so far as we do have a whole lot of nomadic people in this planet that are actually living in houses that are not cubes. They tend to have round houses, huts, or tents, yurts that they can take away with them. But civilized people have begun to make their houses in that kind of sense of having orthogonal, as they are called, orthogonal walls like this, and a normal orientation of the whole thing. Yeah, so why is that a problem? Or not? Let's see. If I am to make that house, the first thing that I'm going to do is I need to, well, where do I begin? I actually haven't built a house yet, and I won't that way, I hope. But I think the first thing is to make sense of 2 directions. One direction is what we call vertical, like these ones. 4 of them. And then we have horizontals, which are these ones. And within those, the verticals to one another are supposedly parallel, as well as the horizontal parts. Those are supposed to be parallel too. Okay. How in the world do we know what a vertical is? Well, the easiest way to find the vertical in your place, wherever you are, is to take a plumb weight. And I got one here. And you can see how this is showing me a supposedly straight line, which is only so straight because there's weight on it. It's being taut, pulled tight, pulled straight. And this one, whatever I do with it, and unless I start spinning it about, which I could, if I don't spin it, it's going to point what we call down, which is incidentally into the earth. So this is a vertical. Now bear in mind, would you, that I'm standing on a sphere. Maybe not right in the Pacific right now, I'm standing somewhere else. But if I'm standing on that sphere and I have my vertical coming from that sphere, what's going on there is that actually my vertical is a radius of that sphere. So let's take a look at this one here. This is another story in itself. We will come to that on another point. This is the mother of all spheres, or vector equilibrium, and you can see how it is. It's got what we could call a surface, even though there is no surface, and it's got these radii that radiate out from the center, and that center is the center of gravity. It's the heart of our sphere. So if I'm finding a vertical, what I'm finding is the connection from the place where I stand, the shortest way into the center of the earth, like this. See? That's a vertical. But you may notice that if I were to move around that earth and that kept pointing into the center, then how could this be parallel to that? They aren't. Radii can never be parallel. If you have any radii, they are always divergent or convergent, depending on the direction you travel along them. So these two verticals cannot be parallel. So in the same way, if I do that on this planet here, if I take two verticals, they are not parallel. Even if I come very close, which would be the case in our house, this is so small scale, one could say, that it seems like these two are parallel. Like if I take two verticals here where I stand, they are almost parallel to a degree where I can't tell they are not. I would have to get up, I don't know, a kilometer or two before I would notice them going apart slowly. So it's easy to mistake, right? But still, the point of the matter of fact is actually we can't have parallel verticals. See how strange it looks if I were to put that big cube on the earth. Those lines do not meet the center of our earth. They won't. Okay, so much for the verticals, which leaves us with the horizontals. And to find out the horizontal, which also is called level, we have a tool called a level. It's some piece of wood or metal or something with a tiny little tube in it, and within the tube there's some liquid, maybe oil or water, and within that there's a bubble of air. Right? And if what we're measuring is level, then the bubble of air is going to be in the center of our little tube. Cool? So far so cool. But thinking about our Earth as a sphere again, now if this is my level, which is the circumference of my sphere, if this is my level, if I move over some point, it's going to be in a different direction. Because as a matter of fact, the horizon that we come to with the horizontal is actually a sphere too. And whatever line we draw on that is going to be a line on the circumference of a circle or a sphere. So it's never going to be straight. it's always a curved line, right? So how, again, are we supposed to have parallel, straight planes and lines that are horizontal? That doesn't make any sense. Unless, of course, we bear in mind that the people who made up this frame of mind, this frame of thinking, were actually believing the earth to be flat. And incidentally, a lot of people do today too. Now, the point I'm trying to make here is actually that everybody who still believes, for better or worse, in the existence of 3D reality, what we call static space, everybody who believes in that is also per definition defining the earth as flat, maybe as a cube, I don't know. I don't really know what shape it would be then. But it couldn't be a sphere, because in a sphere you cannot have parallel verticals and parallel horizontals. Okay, that's a lot, I know. But it is important to think about that, because we are not usually. And we make believe that these things are just so, when they are not, actually. And one last thing about that house, building that house, is, you know how if we want to have a wall made of bricks, for instance, we are thinking that it needs to be straight up, because all the parts that we put on top are going to push on what is beyond them, below them, right? So we're building a brick wall, all straight up like so, this wall behind me, in fact. And if we were to get out of the vertical there and make it a bit like this or that, it would just collapse, because the weight is drawing it into the earth, and unless it's very much balanced in the vertical, it's gonna fall down, which is what happens when the earth is shaking, which she does sometimes. We call that earthquake. It's not good for static static constructs. Let's call them constructs, because they are not structures. If they were structures, their primary ingredient would be the triangle, because that is the sole structure in the universe. If we have something that is a construct, it is something that comes with structure, construct. And that is what this cube would be, because we have the structure in the thing. We put it in as a secondary attribute. But it's never the first thing we have in mind, because if that were the case, we would call this the normal, if need be. I wouldn't call it normal, I don't like the word, but this would be our logical unit of relationship, whereas these would be very much irrational. And it turns out, if we do that, if we do shift that definition, we get to a very funny place, because it turns out where this is a normal frame, only cubes make sense. I mean by that only a cubic volume can be rational, only a square area can be rational, or square or rectangular at least. Whereas no triangle can ever be rational, no triangular area, nor can any other shape but the cube have a rational volume. That is a side effect of that definition that we carry with us. But I can tell you that actually, if we shift the frame of mind and consider the four eyes in there as our rational unit, then its eyes, the triangles, give us a unit of area, which is rational. It's just one eye is one unit. So, this four eyes would have a surface of, if there were a surface, which there isn't on this one, but you can see, if I take this one, oops, sorry, Don't drop stuff on the cat. Okay, this is well prepared, obviously, because I'm gonna take something out of the off, which I actually tied onto something else. Okay, here. See, this is also a 4 eyes, but this has much more of a surface. This has something where I can barely put my fingers in because the eyes are getting so small. But you can see how this would be 4 times 4, which is 1004 or 16 of these eyes in there. Right? So using eyes for area is very simple to use. And a hexagon, for instance, like this one, would just be 6 eyes, right? Still very simple to make sense of it. Completely rational. Unlike a hexagon that we want to know the area of in what we call cubic meters. No, square meters, sorry. Square units, no rational hex, no rational triangle. But if we do take this as our frame, the unit of volume that this is, which we can call a quanta, this quant of a volume, this would be 1, right? Now if this is 1, then, well prepared as always. Let's take this one. Is that? It's almost the same size. Okay, in this case, I'm gonna move this into the frame. Maybe we can see it now. Well prepared, Strupi, as always. Well prepared. Okay, I'm gonna have to make yet another model, but I can show you what I'm looking for. I'm looking for this shape, but in the same size as this one, which means having this shape with the same kind of length of the edges as that one, right? So this is an 8 eyes, this is a 4 eyes. Guess why? It's got 8 eyes. And it's got a volume, if it were the same dimension, the same length as this one, if they were equal in that sense, when this has a volume of 1, this has a volume of 4. 4 times that. Doesn't mean you can fit this 4 times into it, but you could fill it with sand or water 4 times and it would fill this exactly. It's not 3.956757x. No, it's 4 times the volume. While this thing here, which is really, actually this is the leftovers, this one is the leftovers from cutting this in shorter from that length. So you can see this is exactly the same straws. This is the second half of them by cutting them in 2 pieces each. And it's the same string running through them. It's 12 straws each. But while this one does not have any structural integrity whatsoever, this one does very much. This is very, very stable and strong. Same stuff, different outcome. And the difference is in shape. So if this, again, considering it with the same length of edges as this one would be, if that has a volume of 4, let me just show you this cube again. Because if I put it in here, and we have a cube that is a cube, or could be considered a cube, the volume of that cube in quanta, the quantum volume, quanta volume, turns out to be exactly 3. Okay, so let's think about that for a second. this thing here, this structure, or construct now, it has a volume of 3 times the thing in the middle here, the 4 eyes. 3. While the 8 eyes that we could have made from those same straws, as I've done here, if it were in the same size as the green straws on my 4 eyes, the 8 eyes would have a volume of 4 times the quantum, without having to put this in. So I need less stuff to get out way more place, way more room, way more volume. Alright? Okay, I guess I made the point clear enough for now. As always and forever, and with these things, what I'm talking about here, the way of the spheres, there's a lot more to talk about. There's so much more that we can know from looking and playing with these structures of space-time. Way more stuff that we can learn about the reality that we're living in, and way more ways of interacting with this world, relating with it, making our houses, making our furniture, making our everything that we need in life with a new frame. It's a good thing, and it really does make a difference. But we're not gonna go any deeper into this stuff for the moment, because that's a whole different, it's not a different story, it's the same story. But I guess if you've held out this long, you've noticed that we can really, really talk and talk and talk long and broadly about this, and there's still more to say. So instead of doing all of that at once right now, I'm gonna keep it at this place and leave you with that sense that actually there is something, a whole world around us and within us that we are not familiar with due to the framework that we've inhabited from our forebears, from the patriarchs and conquerors and colonizers and people that have made the world their subject, that have shaped the world in a resemblance of the frame of mind they've been carrying with them. Within that frame of mind, the reality of our existence is rendered invisible. The diversity as the basic and fundamental nature of this universe is rendered abnormal. It's a problem, so we need to eradicate it. We need to take away everybody who doesn't fit in that framework, be they nature as she grows or people as they grow, who are part and parcel of that nature. Alright, so here is our takeaway. We can make sense of a volume called a cube. We can create that only and exclusively by putting in the triangles that we do not take into account usually, leading to quite a lot of trouble and problems in terms of, universe having its pattern integrity and our whole anthroposphere being an anthropocube. It's not really using the same pattern integrity. We're at odds with the world. We're at war with it, really. But we don't have to be, because as Bucky, who I learned this from, Richard Buckminster Fuller, pointed out to us, you can render that whole system, he did actually render that whole system obsolete. We're not dependent any further on that framework of nonsense, we can free our common sense from that nonsense and reintegrate ourselves into the greater whole that we have grown out of. And maybe as a last takeaway from this, and again, I could talk for 4 hours on this, and I will, and if you want to learn more, please come back or get in touch, and we could also talk one-on-one, which is my preferred way. But one last takeaway from this. So if the basic starting point of this way of the spheres that we've just taken a look at is a sphere as somebody with a heart, which is the point of that body. It's the point of convergence of that body, center of gravity. Now, if that sphere is somebody, what they do have in common, what everybody has in common, is that they have two sides to them. And those two sides are inside and outside. If I have, and I'm looking for one here, let's take this one. If I have a sphere like this, see, we have the outside here, and we have the inside here. And we have the skin or the membrane that is binding those two together. And we think of a boundary as something that is dividing, separating, when really it is binding together two sides of the whole, the inside and the outside. One being concave, meaning collecting everything that comes in, whereas the other is convex, meaning dispersing everything that it needs, reflecting and giving back. Now, if I am my inside, which I truly am, I am aware of that, because I can touch myself somewhere and feel it from inside and outside. If I am my inside, I am also my outside, because those two are not separate at all. They are bound together by my skin, which is the connecting tissue between both my inside and my outside. And I can tell you one more thing, our common outside is also our common inside. We have that in common. We are the same whole. We're just a different little bit of that. But that means, while we have been bamboozled into thinking that we are separate from this place, that there is nature and there's culture, there is animal, plant, and planet, and then there is human, separate from all of that. That's nonsense. We're absolutely interwoven with this greater organism called universe. And I, for myself, find a great sense of ease, of release, of hope and wholeness in knowing and recognizing that whoever I meet in this world is my other, meaning part of myself, my outside self, but not separate from me, not something I need to be afraid of because it seems to be different from me, but instead something I can embrace. I can embrace the difference, because the different point of view, the different set of senses that comes with anybody else but me is something that is complementary to my own. And the more diverse and differentiated this interplay of somebody's and everybody's is, the more beautiful this place is to live in, the more healthy, the more resilient, the more wonderful, really. So, with that in mind, to quote Alan Watts, my friend, if I am my foot, I am the sun. And if I am my own, I am my other. And if I am here, I am sphere, and I am sphere with you. And I'm glad you were a sphere with me too. Have a good day.